So here we're gonna study about implicant, prime implicant, and essential implicant. So these are all related to the simplification procedure. So actually, it is very hard to understand with these verbal descriptions. So let me give you some more details with examples. But before starting, let me give you some idea about implicant at first. So here, if we have some one mark in each space, then we are saying that these are all implicant, okay? This is implicant, this is also implicant, and so forth. And then now we're gonna see what is the prime implicant. Prime implicant means that among the implicants, this is the biggest one, okay? So here, this is prime implicant, okay? We cannot draw bigger than this one, okay? That's why this is the prime implicant. So this is A prime D, okay? And then this is also prime implicant. So this is B D prime. So this one, okay? And lastly, this is also prime implicant. We cannot draw bigger than this one. So this is A prime B. So this is same with this one, okay? So, and then you can see that the blue one is dominantly covered by the red ones. That's why we can skip this one, okay? This is kinds of the simplification. So now we're going to see what is the essential prime implicant. This is very important. So here, this is essential prime implicant. This is essential prime implicant. This is essential prime implicant. So this means that, so we will draw these ones with the different colors. B, C prime, B, C prime, D, this one. So next we have this one, A, B, C prime, A, B, C prime, this one. Lastly, we have this one, A, B prime, C, A, B prime, C. We have this one, okay? So what's the difference? So here, you have to focus on these yellow ones. So these yellow spots cannot be covered by the others. So this yellow one should be covered by this red one. This yellow one should be covered by this blue one. This yellow one should be covered by this black one. With the others, this cannot be covered. That's why this is called essential prime implicant. So these three are essential prime implicant. For example, if we have this one, this can be covered by this one, or this can be covered by this one. That's why this is not a prime implicant. But the implicants, which includes the yellow spots, can be essential prime implicant, okay? So here, since yellow spots should be covered by red one, blue one, and black ones, we have to get them for sure. So we need this one, we need this one, we need this one before starting. Then we can cover these stuffs, okay? Then we can focus on the others. For example, in order to cover this one, we can have this one or this one. That's why we can have this one or this one. For this one, we have this implicant, okay? So selection rules. So here we can see that this is the one, this is the one, this is the one, and lastly we have this one, and that's it. We may have this one and this one, but they are dominantly covered by the blue ones. That's why we don't need to worry about these ones, okay? And then we have the other trick. So here, when you look at this one, the ones are very complicated, but when you look at the zeros, we have these ones, this one, and this one, and that's it. Or, yeah, and that's it. So this is kind of the complement of our desired solution. That's why this is our solution, this is complement. So then we can have A, B, and C, D, C, D, this is A, B, and then lastly we have B, B, D prime, B, D prime, okay? And then when you take the complement of this one, then by the De Morgan's rule, we can get this final result. So this is our desired solution in this case. That's why we can take the complement of at first. After finishing the calculation, then we can take the another complement, then we can get the desired solution. So now we will gonna see what is the don't care condition, okay? In the don't care condition, so this map is just for letting you know the numbers in these right-hand side figures. So you don't need to worry about this one too much. Now you can see that 1, 3, 7, 11, 14, these are all our ones here. And then don't care terms are 0 to 5. These are don't care terms, these ones. This can be 0 or this can be 1. You can take one among these two based on your preference, okay? So now you can see that, okay, you may have this one and this one, okay? Then this is the one, these are zeros. Then we have this kinds of simplified result. So don't care term is very easy and it can make problem very easy, okay? And in this case, you can take the complement of the complement at first. So here, the complement will be this one at first, and then this one, okay? And then the others, this one will be our desired solution. That's why for the complement, these are our D prime, because this is D, and then this is AC prime, so AC prime. This is our complement. And then when you take the complement again, and then by the De Morgan's rule, we can get this final result. So we can get the result just like this way, okay? Then we can take this result. Then this x becomes 1, the other x becomes 0, okay? So here, you have to understand, lastly, I want to focus on the phase 1. So here, how many implicant what we have? So 1, 2, 3, 4, 5, 6 first, and then 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, and lastly 1, 2, and eventually 19. I'm not sure. So then, I mean, what I want to say is that so the implement can be 2 or 4, whatever you have. Okay, so not only the single space. So you have to remember that as well. So this is the end of the chapter 2, and next time on Tuesday, the teaching assistant will post one lecture slide and video. The video is talking about the installation of your project toolkit. So you can start the VHDL and Verilog programming based on that. And then the TA will post another video which is introducing some implementation for our chapter 2. So you have to watch the videos, and then you can start to have some exams based on that. Actually, during the midterm exam, I'm not sure whether we can take the exam or not, but I would like to give you some large scale project in order to, instead of the midterm exam. That's why you have to keep in mind that you should be very familiar with the toolkit. Thank you, and see you next time.